This is the lecture for lesson 26. This section covers hyperbolas, and they're only going to be centered at the origin. We are going to be able to locate the vertices foci of a hyperbola from the graph, as well as from the equation. We will write the equation in standard form, and lastly, we'll be able to graph some hyperbolas. This image shows all the parts of a hyperbola. Starting with the vertices, we will have two. We will also have two foci. Our center is going to be at the origin, so every single time we will go through the origin here with our asymptotes. There will be two asymptotes. So you'll see these here. And we also have co-vertices that are going to be on the other axis that our graph is not. And just like before, we can have a hyperbola or a ellipse or any of these conic sections can open along the x-axis or they can go on the y-axis. So we will be able to see some on the y-axis as well. First thing we're going to do is look at a graph of a hyperbola, pick out the vertices and the foci. So the vertices are going to be where the graph is going through, and the foci are going to be the other points there. So this one is clearly along the x-axis, and that's at 1, 2, 3. So what's on one side is going to be repeated on the other side. So 3, 0 and negative 3, 0. And then the two foci are at 5, 0 and negative 5, 0. If we look at the next one, again, you'll see these asymptotes go through that center point here, but we're looking for the vertices and the foci. And it looks like in this one that we're counting by twos. So our vertices on this one, what is that, 12? So 12, 0, negative 12, 0. And then the foci, so 12, 14, that's going to be 15. 15, 0, negative 15, 0. Now we have our table with all of the pieces that we can find from our equation. When you look at the equation, it's going to look similar to the ellipse, except that we have a minus sign. In the ellipse, it was fractions, x squared over a squared, y squared over b squared with a plus equal to 1. So the giveaway for hyperbola is going to be that it is now a subtraction sign. Now, one other difference that you're going to need to know here is with a hyperbola, a is always under the first one. And whatever the first one is going to determine our vertices. It does not have to be the largest one anymore. It is just which one is first is going to be our vertices. So some other things we can remember, our vertices are always then from that a value, in this case our first value, not the largest. So when that's under x squared is the first one, your vertices are on the x-axis, positive and negative a. When that is under y squared, under the first term, then your vertices are negative 0, a, 0, negative a. B is only used to help us determine our foci. That is going to be with a slightly different formula as well here now. So the foci here are c squared equals a squared plus b squared. So you're going to need to know which formula goes with which piece. Again, a reason to copy this table down, print it, or find a similar one. The last thing we're going to have are asymptotes. And if it is x first, we're going to put y equals b over a or negative b over ax. When y is first, it's going to be a over b to determine the slope of x. So again, a few different things we have to remember depending on the type of equation we're working with. So now we're going to take that equation and actually find the vertices, the foci, and the asymptotes. So looking at this first one here, we have y squared over 144 minus x squared over 81 equals 1. Y squared is first, means that the y is going to determine our vertices. And a is going to be the square root of that, or 12. So x is going to be the second one. It gives me b squared to 81 is 9. I will find c quick. C squared is a squared plus b squared. So I'm going to add 144 and 81. When I add them together, I get 225, which is nice because I can perfectly square root 225 and get 15. So our vertices are on the y's, so 0, 12, 0, negative 12. We have our foci, which are going to be along that same axis, so 0, 15, 0, negative 15. And then the last thing I need to do is my asymptotes. When y is first, we do a over b. So y equals plus or minus, a is 12, b is 9, x, so 12 ninths x, and I can simplify that. That is 4/3 x. Positive and negative 4/3 x for my asymptotes. When I look at number 4, this one starts with x squared over 25 minus y squared over 4 equals 1. So for this, the x is first. So that is our major axis. That is where our hyperbola is going to have its vertices. So square root of 25 is 5. So the next is the y, gives me the b is the square root of 4, or 2. So if I do this one now, a squared plus b squared, or 25 plus 4, that gives me c squared is 29. I cannot square root 29, so I'm just going to leave it as c equals the square root of 29. That's going to give me my vertices and my foci. So now remember, x was first, so it's going to be 5, 0, and negative 5, 0. And the foci will be root 29, 0, and negative root 29, 0. Because we now have x first, we will do b over a to determine our slope here of our asymptotes. So y equals positive or negative 2/5 x. And then we have one more here. We have x squared over 9 minus y squared over 144 equals 1. So here's where I said a is not the larger number. A is what's under the first number. So the first one is x. A is the square root of 9, or 3. Y is the second number, so it determines b, square root of 144, is 12. We can then find our c squared, which is 9 plus 144. If I add those two together, I get 153, which if I square root, let's see, that's 9 times 17, I believe. So 3 root 17. X was first, so my vertices are on the x-axis. 3, 0, negative 3, 0. The foci are also on the x-axis. 3 root 17, 0, negative 3 root 17, 0. And then the asymptotes are going to be b over a. So let's see, b 12 over 3, positive or negative 12 over 3x, which is positive or negative 4x. Next thing we can do is write the equation in standard form. Remember, we need fractions, x squared and y squared over values is set equal to 1. So we have 25y squared equals 225 plus 9x squared. We need to write that in standard form. So the first thing I need to do is y and x need to be on the same side. So I'm going to subtract 9x squared over here. So I have 25y squared minus 9x squared equals 225. The last step then is we want what's on the right side to be equal to 1. So the only way to do that is to divide everything through by 225. When I do that, I'm going to get y squared over 9 minus x squared over 25 equals 1. So 25 over 225 is 1/9. 9 over 225 is 1/25, and 225 divided by 225 is 1. All right, next one already has the x and y on the same side. We have 16y squared minus 9x squared equals 144. So for this one, all I need to do is divide everything through by 144. So 16 over 144 is 1/9. 9 over 144 is 1/16. So y squared over 9 minus x squared over 16 is going to equal 1. Number 8 gives us our vertices and our foci and asks us to go back to the equation. So vertices 4, 0, and 0, 4. So that means x is first. So x squared over something minus y squared over something has to equal 1. And we can determine a because, well, that's a right there. So a is 4. That means x squared is over 16. Now all I need to do is find b. So if a is 4, and we have our foci, so we have c, 2 root 13. Now we need to work backwards to find b. So we know that c squared equals a squared plus b squared. So 2 root 13 squared equals 4 squared plus b squared. Now, 2 root 13 squared, you could type that in a calculator. It's going to give you 52. So 52 equals 16 plus b squared. And then I'm going to subtract 16 from both sides. And I get 36 equals b squared, which is what I need to go under here, 36. So my equation is x squared over 16 minus y squared over 36 equals 1. The last thing we're going to do is put it all together and make our graphs. So we have x squared over 49 minus y squared over 100 equals 1. So that means our vertices are going to be on the x-axis because a is 7. So 7, 0, negative 7, 0. Let's see, b is going to be 10. So let's find c so we can find our foci. So c squared equals 49 plus 100 or 149. So what I'm going to do at this point is I just need to know the decimal version to know where this is. So c is going to be the square root of 149, which means our foci are the square root of 149, comma 0, and negative root 149, 0. And the square root of 149 is about 12.2. About. And then the last thing I need are my asymptotes. And when x is first, we put b over a. So y equals positive or negative 10 over 7x. All right, so here's how we're going to do this. I'm going to scale my axes by 2. So my axes are going to be by 2s. All right, so I need to go 7. So 2, 4, 6, 7. 2, 4, 6, 7. And that is my vertices. I need to go to 12.2. So 2, 4, 6, 8, 10, 12. A little after is my foci. And reflect it on the other side. Now I'm going to make my asymptotes here. So I need to go up 10 over 7. So from the center, 2, 4, 6, 8, 10 over 7. And then I'm going to go, basically what's going to happen is I'm going to create a big square here. big box. So it's going to go up here. And then you can see that if it repeats, goes over there. And then I need to go down. What is it? 2, 4, 6, 8, 10, 7. So this asymptote cuts back this way. So they're all going to be exactly above and below the vertex. So 10 up from the vertex, 10 down from the vertex, 10 up from this vertex, 10 down from this vertex, because that gives me that slope of up 10 over 7 and then down 10 over 7. Okay, then the last thing you're going to do after you draw that is draw your hyperbola part from your vertex going to your asymptotes. Next one, x squared over 64 minus y squared over 9 equals 1. Given that the x squared is first, my vertices are going to be on the x-axis using a equals the square root of 64 or 8. So 8, 0, negative 8, 0 are my vertices. Next, I'm going to find my foci by needing to find my c squared by adding 64 and 9 together. So 64 plus 9 is 73. So c is going to be the square root of 73, which, 73 is about 8.5. So our foci are root 73, 0 and negative root 73, 0, or about 8.5 and negative 8.5 and 0. Okay. Last thing I need to do is find my asymptotes. Again, x is first, so we're going to put b over a. So positive or negative b. Well, we need b, so let's see. B is the square root of 9 or 3. So 3/8 x. Again, I'm going to scale by 2s. So 2, 4, 6, 8. 2, 4, 6, 8. I'm going to make my foci in just a little different color because it's going to be right after that point there. And then going from here, I'm going to go up 3 over 8. So up 3 over 8. Down 3 over 8. So from my vertex, I have to go up 3 and down 3 so that I can make my asymptotes through those points. And then the last thing I do is draw my hyperbola towards my asymptotes. We have one more. Y squared over 36 minus x squared over 81 equals 1. So the first one has y squared this time. So the vertices are going to be y. Using a equals 6, that's the square root of 36, and b is going to be the square root of 81 or 9. So the vertices now are going to be on the y, so 0, 6, 0, negative 6. And again, for this one, I'm going to count by 2s for my scale. So 2, 4, 6, 2, 4, 6 vertices. Next come my foci. I need to find c squared, which is going to add these two together, 36 and 81. So if I add those together, c squared is 117. And when I square root, this one does actually break down. That's 9 times 13, or 3 root 13. But in decimal form to help us is about 10.8. So our foci are on the y, so 0, 3 root 13. 0, negative 3 root 13. All right, so 6, 8, 10, 10.8. 6, 8, 10, 10.8. So there's my foci. And now last, I need my asymptotes. When y is first, we put a over b. So a is 6 over 9. And let's see, that reduces to, it would be 2/3 if you want. So starting here, up 2 over 3. Remember, I'm counting by 2's. Up 2 over 3, up 2 over 3. So you can see from my vertex, I have gone over enough. So down 2 over 3, down 2 over, I did not go over far enough. Hold on. Up 1, 2, 3, that should be there. Up 2, 1, 2, 3. There we go. Because I should be 9 away from this one. So 2, 4, 6, 8, 9. There it is. 2, 4, 6, 8, 9. 2, 4, 6, 8, 9. It kind of makes a little box here that your asymptotes go through. And lastly, make your hyperbola. All right, that is the end of this section. You can do the homework, and this is actually the end of the module. So short module, we will be having a test very shortly.